start the recording and we're going to go through. So since it's just me and you live, we're going to go as quickly or as slowly as you would like. So if we do an example and you got it, you can say, hey, we're good. We don't need to do another one. Or if you say one more would be good, whatever you need is what we're going to do. So this week we're covering 4 sections. 22 is the last financial piece. So the retirement and savings plans. 23 and 24 go together with absolute and relative change. And then 25 is the first half of 25 and 26 that go together. So depending on time, if we need to push 25 to next week, we can, because 25 and 26 go together really well, and 27 and 28 go together really well. So even though those are 4 sections, they're going to go pretty quickly. Hi, Kara. Thanks for joining. But again, it's kind of whatever pace we need to go at today, and that's fine. So we do have an Excel assignment here with the mortgages, and I do have a video for that. 2 quizzes this week. One, mortgages, 401k, and an Excel piece, and then a quiz with absolute and relative change. So that mortgages and 401k is kind of sections like 21 and 22, and then the quiz for absolute and relative change is 23 and 24. So, and then you have a discussion board as well this week. So, all right, if there's no questions, then we're going to jump in, okay, to section 22. There we go. All right, so earlier, sections 20 and, section 21, hi, Christian, good to see you. Section 21, we got into our first Excel formulas, and those were using the PV function and PMT. So if you remember those from the mortgage section, the PMT function was finding the payment for a house, a boat, a car, anything that you were buying. And PV was finding the present value of a house, car, boat, whatever you're buying. But the inside pieces were pretty much the same. And now in section 22, we're getting into retirement and savings plans. We have a new Excel function. We call this the FV function. And the FV stands for future value. So if you think about retirement or savings, you're saving for your future. And so future, the FV implies the future value. So look inside again, we have our monthly rate, the number of deposits, and then the amount deposited per time period. So if we're depositing $100 a month, well, that would be a minus 100 there. So the inside piece of this formula is very similar to the inside pieces for the PV and the PMT functions. So all of them are very similar. The big difference is the letters at the beginning. As long as you know what those letters stand for and why you're using them, it'll go pretty quickly or pretty easily for you. Okay, so let's actually get into something here. So our first big thing that we're going to jump into is, how does a 401k contribution affect take-home pay? Because many people say, well, I can't afford to invest in a 401k because I live paycheck to paycheck and I need every penny of my paycheck, right? Struggle is real. I did that for many, many, many years. And so really, how will this affect our take-home pay? So that is the example we're going to look at. All right, so Tim earns $48,000 annually. He pays 18% taxes. How would investing $150 into a 401k impact his take-home pay? There is an example like this in your packet. So if you need to see another one, you can always go back and watch the video for this. This is the first page in the packet. So, okay, so we're going to do, you can kind of see this black line down the middle here, separates this into 2 distinct problems. So the first thing we're going to do is we're going to focus on before investing. So first we're going to say Tim does not invest in a 401k. We can figure out his take-home pay. So this is kind of our process here. First, we are going to start with his gross monthly pay. Remember that gross pay is before taxes. So if he earns $48,000 annually, how much does he earn per month? Anyone? It's $48,000 a year. How much is it per month? How would we figure that out? 4,000, exactly. We would take that, we would divide it by 12 months, and his gross monthly pay is 4,000. Okay, now, the left and the right side are identical. Less 401k, less means to subtract. Well, in our first example, Tim is not investing in his 401k, and therefore $4,000 is his taxable income. Okay, well, now we're going to take away his taxes. So how do we figure out how much he pays in taxes? If he's paying 18% in taxes, well, what is 18% of 4,000? So we take 4,000, we multiply by the 18% as a decimal. $18 times 4,000 gives us $720. So Tim's going to pay $720 in taxes. So if I take his gross income and I subtract his taxes, we get his take-home pay. So Tim will take home $3,280 a month when he does not invest in a 401k. Okay, so that's before investing. Any questions on that concept? It's kind of like how it's figured. Okay. On the right-hand side, now he's going to invest $150 per month. So his gross monthly pay does not change. Tim is still earning $4,000 a month, but now we're going to take away his 401k contributions because they go in pre-taxed. So his taxable income is only $38.50. So kind of the incentive of investing in a 401k is that you're taxed on less money. And if you think about it, if you're paying tax on less money, you're going to pay less taxes. So when we're looking at this, if he paid his taxable income is $38.50, we already said he's in the 18% tax bracket. So 18% of $38.50. In this particular example, I need to change colors. That gray is not a good one. He's only going to pay $693 in taxes. So if we have his taxable income of $38.50, subtract the taxes that he pays, which again I found by taking 18% of that $38.50, he's going to take home $31.57. Have I lost anybody in that process? Because this is kind of an overarching idea of how to compare, before. You do need to know your tax bracket in order to make this work. But okay, and hopefully you guys have that written down because we're going to need those values to answer the next page. But we can read the questions. Okay, so on the next page of questions, what is the difference in take-home pay, which those are the circled values, and what is the difference in paid taxes? So, first things first. What is the difference? Difference in take-home pay. $123. Excellent. For some reason, I do not have these answers on my sheet. $123. So even though Tim invested $150 into his 401k, his paycheck was not reduced by $150. It only was reduced by $123. And you might say, well, $123, I still need that money to pay my bills, and that's legit, right? It's possible. But it's also not as much as you think it's going to be. Now let's talk about taxes. What's the difference in taxes? $27. Very good. So you can see together the savings of taxes and the difference between taxes, the difference between your take-home pays together give you the $150 that you initially invested. And that will always work out that way, that those differences will add up to that amount. So you will pay money on this or taxes on your retirement when you take it out. So after you retire and you withdraw from your 401k, that's when you pay taxes on it. The thinking is you'll probably be earning much less when you retire, and therefore you'll be in a lower tax bracket. So in the long run, you will still pay less taxes because of how the tax brackets are figured. Right? That's kind of the goal of paying taxes on this money later. All right, so this is a traditional 401k, not to be confused with a Roth IRA, which is after taxes, right? Completely different. Okay, questions on that one? Okay, so that's kind of just looking at the difference in retirement, which a lot of people don't know how those things are calculated, so it's always good to kind of have an idea. And you can see I had humor me written there. I don't even know what that's about. I made this a while ago. I'm guessing I had something to say about it, but I don't remember. Okay, so now we're going to do this is our last example here in section 22, so we're good. It's hard to read all of that, but Tim invests $150 a month into his 401k and his company matches 50%. And that's super nice. If you work for a company that matches anything, that's great. If the rate of return is 3.4% and Tim plans to invest for 35 years, we're going to answer some questions. How much is invested each month? Right. Tim invests $150 and his company matches 50%. What does that mean? $225. Kara, how'd you figure that out? Good. Yeah. If they 50% of that, so what is 50% is half of 150? Well, half of 150 is 75. So the 150 that Tim invests plus half of that, which is what the company matches, together is 225. So Tim in his 401k is getting 225 per month. Okay, so now what would Tim type into Excel to see his total after 35 years? So we're looking for, right, futuristic. So we're looking for FV, and this is exactly how you would type it into Excel, right? Equals the letters FV. Then we start with our monthly percent because we're talking, right, we're making these deposits every month. So first I start with my percent, and you can write that as a percent because Excel is a calculator, or you can change it to a decimal. It's really up to you entirely because mathematically it's the same thing. I'm a big fan of decimals. I don't know why. But again, that's an APR, right? That's the annual rate of return. So we are going to have to divide that by 12 to make it a monthly rate. In the middle, I have the number of deposits being made. And Tim is doing this every month for 35 years. So I can take 12 and multiply that by 35 years, or you can go ahead and just multiply that out and get what, like 400, I don't know, 420 maybe, something like that. But number of months, and at the end is how much is going in. Well, that's the 225 from Part A. So that's what you would type into Excel. Okay. When it comes to the exam, you're not going to have Excel available, but you are going to be expected to know the difference between these formulas. So if I say you've got to find the future value for this 401k, which of these formulas would you use? And it's a multiple choice question. You would need to know the FV. Okay. If you type that into Excel, you do get $181,182.30. That should be a decimal point right there. Okay, so $181,182.30. That's an ugly looking number that I just wrote right there. Okay, so now let's go for questions C, D, and E. How much of this money did Tim actually invest himself? How do we figure that part out? Any idea? You're definitely only going to play with 150, but you're working too hard. If you think about investing, Tim is giving $150 a month for 35 years, right? But you're right with the 150. So if you think about, he gives $150 a month times 12 months every year, and he does it for 35 years. This is how much he gives towards his retirement. So what would be 150 times 12 times 35? $63,000. Very good. So over the course of 35 years, Tim only invests $63,000. Okay, now think about this. If the company invests half of that, how much did they invest? This is letter D. There's two ways you can figure that one out. $31,500. Exactly. Either could have said $75, 12 months a year times 35 years, or you could have just taken 63,000 divided it by 2, right? Because they did half of it. Okay, so these green numbers are the amount of dollars actually invested. But if you add those together, that only totals $94,500. So how did the ending amount end up over $181,000? How does that work? What's the difference between that? Subtract the difference, we end up with $86,682.30. So the difference between the amount invested, which is the green numbers, and the ending amount, which is the yellow number, gives us the purple number, which is the interest, right? This is the purpose of investing, is that not only is it the money that you put in, but it's also the bank's money, right? Because they're paying you interest, and that's the beauty of it. So the longer you have your money in, this is why they say start investing early, because the longer you leave it in, the more interest you're going to earn. This is generally compound interest, which is why we need Excel to do the math for us, because it's your principal is growing every month with the 220, in this example, the 225 that's going in every month, plus the interest calculations. So it's very exciting. Okay, questions about 401ks, future values. You can get more examples in the packet and watching the videos that go with that. But that's kind of the gist of section 22. Okay. All right. If there are no questions with that, then we will move on to sections 23 and 24, absolute and relative change. These two sections go together very quickly, very easily, excuse me, so that I talk about them together. Okay, so absolute change. When we talk about absolute change, we're talking about a number. You know, if we just real easily talk about 5 to 10, right? The absolute change, we would say this is our old number, this is our new number, and absolute change is found by taking new minus old. So mathematically, I would take 10 minus 5, and the absolute change is 5. Concrete number. If they're asking you for absolute change, they're asking for a number. Now, when you get to relative change is often talked about as a percent. right? So to find it, we're going to take our new value minus our old value, and we're going to divide by our old value. So we're going to start as a fraction and change it to a decimal, change it to a percent. So in our example here, new minus old divided by old. Well, 10 minus 5 is 5. 5 divided by 5 is 1. Now that's a decimal. Multiplied by 100%, our relative change would be 100%. Which makes sense, right? 5 to 10, it doubled. That's 100% growth. So relative change is new minus old divided by old. And I do recommend, right, because those little formulas, whatever, are not on your formula sheet. You use the same formula sheet for exam 3 as you did on exam 2. So you're going to need to know that. So I oftentimes will write n minus o when I'm doing absolute change, and I'll write n minus o divided by o for relative change. Because it's quick. It takes me, 3 seconds to write that down, and it's a visual reminder of what I'm doing. And then that allows me to remember it a little bit easier as well. And that's what you want, right? You don't want to forget what you're doing. You guys can all subtract, divide. Those are things that you can do easily, so you don't want to mess it up because you went the wrong way. Okay, let's do an example. Rent for a one-bedroom apartment was $720 in 2016 and $740 in 2017. So what is the absolute change from 16 to 17? Now, your first question you really need to answer with these is what's old and what's new, right? That's kind of the big thing. So if you think about where you came from, I'm from Ohio. I moved to Indiana. So wherever you're from, that's old. Wherever you're going to, that's new. Okay, so to is new, from is old. And I don't know how you remember that. To is new, it kind of rhymes a little bit. Go with it. But that's what you're thinking of. So because 740 was in 2017, that's my new value. 720 was in the 16, so that's your old value. So when I take new minus old for my absolute change, what do I get for an absolute change here in this example? $20 is correct because 740 minus 720 gives me an absolute change of $20. And it's positive, which means there was an increase. You all can see that, 720 to 740, the price increased. So we would say this has an absolute change, apartment rent increased by $20 from 2016 to 2017. No big deal. Okay, now let's look at relative change in our second one. So now we're looking for new minus old divided by old. So you'll notice the numerator is just absolute change, new minus old, divided by old, which is 720. So when I simplify that, I get 20 over 720. What does that turn into as a percent? Let's go to 1 decimal point as a percent. So change it to a decimal, then to a percent, then round, if that makes sense. 2.8, very good. So for those of you who didn't get that quite as quickly, this is what your decimal becomes. Change it right 2 places. So you get 2.78%, which rounds to 2.8%. So you could say rent increased 2.8% from 2016 to 2017. We often call that a cost of living increase, right, of a certain percentage, right? So this is the basic idea of absolute and relative change. So, okay, I want you guys to try one. You guys try this one. I'm going to give you just a minute or two. All right. Hopefully you guys are either confused or good. I don't know which is which. Here we go. So when we're looking at this one from 02, so 02 is old, to 2010, so that's new. So the 2010 salary here, here's the new one. Here's the old one. So absolute change is new minus old. 40,500 minus 32,000. What's my absolute change? 8,500. Good. And it's positive, so that's an increase. Bill's salary increased by $8,500. Okay, then we go to relative change. New minus old divided by old. So I have my 8,500 on the top, and I divide that by 32,000. What is my relative change? 26.6%. Okay. Thoughts, questions, anything? We good? That process makes sense, okay? All right. The next example, we're not going to do in entirety. I just want to kind of draw your attention to it, that sometimes they give you data as percent already. So in the fall, 12% of adults called in sick. The following spring, 8% of adults called in sick. These are just data. So when you're talking about absolute change, when you are given percents, you talk about them as percentage points. So when I do this, right, here's my new value, here's my old value. So new minus old is 8 minus 12. So we would say -4 percentage points. So from the fall to the spring, the percentage of adults called in sick decreased by 4 percentage points. Because remember, when we're talking about absolute change, it's a number. And when you talk about percent is not a number. So when you throw the word points on there, that gives it a point type of a value. So in the relative change, new minus old divided by old, right, 8 minus 12 divided by 12, I get -4 over 12, which is -33.3%. So from fall to spring, the percentage of adults who called in sick decreased by 33%, right? A third less. Because again, but we're dealing with those percentage points. So don't freak out when you see percents. You can still find absolute and relative change through those two pieces of data. You just have to be aware of what you're dealing with. Okay? Okay. All right, so that's section 23. Now we're getting into section 24, which is more of the same, but we're going to talk about the problems a little bit differently, and that is relative change, as we know, is percents, and so we often talk about it as percent change. So an easy way to do some story problems here is to always think about, you're dealing with percents. Also, 100% is your reference. So if you think about 20% more, well, if I have 100% and you have 20% more than me, then you have 120, right? Because percent is always referenced to 100. So if it's more or greater or anything that implies bigger, you would add to 100 and you get yourself a ratio. Then we could set up a proportion. Okay, and of course we're going to do examples of this, so don't worry. But likely it's 35% less. Well, if I have $100 and you have 35% less than me, then you only have 65. And so again, it gives you a ratio, and you can set up a proportion. So when you read these problems, anything that implies bigger, you add to 100, throw it over 100 because you're dealing with percents. And listen. So that also means if I say we have a 20% increase, well, that would be here because increase implies getting bigger. Or if I say something decreased 35%, decrease means it got smaller, that would give us this ratio. So the word increase and decrease also imply relative change. That's kind of the key word there because there are some I think in section 20, it is 24, there's some wording, people get confused, but if you can identify the word increase or decrease, that identifies the percent that goes with 100. Okay, enough of me talking, let's do a problem that's actually going to make some sense. So there are 25% less students in math classes when compared to English classes where there are 800 students enrolled. How many students are enrolled in math? I'm like, well, this is crazy. So I always start with the percent. 25% less. Am I going to add or subtract from 100 if it says 25% less? Subtract. Yeah. Don't use a question mark. Be proud of that answer. Yeah, it's less. That implies we take away. So if we take 100 minus 25, that gives us 75. So half of our ratio, or our proportion, excuse me, is the ratio 75 over 100. Now, this is kind of where people start to get confused. They say, okay, I get that, because less means subtract, and okay, got it. But how do I know where that 800 goes, top or bottom? So think about this. There are 25% less students in math when compared to English. So right now I have two numbers. I have 75 and 100. One is clearly smaller than the other. Who has less students, math or English? Math, exactly. Math has less students. So math is represented on the top, English is represented on the bottom. So ask yourself that question. After you get your ratio set up with your percents, think about whatever you're talking about, whatever you're comparing, which one has less or which one has more, and get yourself a label. Because we know there are 800 students in English. Well, English is on the bottom, so 800 goes on the bottom. How many students are enrolled in math? That's what I'm trying to figure out. And now I have myself a proportion that I can solve. So I go back to my idea of cross multiplication. And how many students are in math? $600, exactly. Okay. I know that you can solve proportions. You did that really, really well. I mean, for the first 2/3 of the course. So now it's a matter of setting them up using those percentages as your guiding piece. Okay. All right. I want you guys to try one. Go ahead and give me a yes. Don't give me the number. That way everybody has a chance. But type yes in the chat box when you have it figured out. Okay. Or if you get stuck, feel free to type no in the chat box. Either one is fine. We're going to talk about it either way for our folks at home who are watching the video. All right, so we have one yes. Not sure if it's right, but a yes. Okay, second yes. Got a third yes. And a fourth. Okay, so let's check it out. All right, so we start with the 15% more. So what ratio do you start with because of that 15% more? So far, so good. 115 over 100. And then you ask yourself your question. Okay, I have Sarah and I have Tina. Who has more flowers? Sarah has 120, which is more than Tina, right? So Sarah has more. So Sarah's on top, Tina's on the bottom. And Sarah has 120. So 120 goes here, Tina's goes here. So how many flowers are in Tina's garden? $104? Is that what you guys got? Yeah. Makes sense? Everything good? So when you read the 15% more or less, decrease, that kind of thing, that implies the change. Okay, what time is it? So far, so good. Okay. All right. Stan earns $18 an hour. He gets a 15% raise. So how much is he earning now? Okay, so I'm going to have you guys do this problem next. You're going to use your answer from A to then work on B. Okay, so kind of a progression. You start with the $18 an hour. He gets a raise, gets a new wage, and then he gets a pay cut based off of his new wage. Okay, so try this one, number 6. I'm going to give you maybe 2 minutes, and then we're going to talk about it, because I do want to, we got a couple more problems to get through today. 1 minute warning. Okay, when you're doing these problems, it is super duper important that you really follow whatever they say. Don't think that, oh, it's a 15% raise. Well, that means it's the same as 85%. No, 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 no. A 15% raise means more than 100. So you have to use 115 over 100. You can't kind of work backwards. Percents do not work that way. So in this first piece, Stan gets a 15% raise. Raise is more than what he has, right? So the 115 would be his new wage, and the 100 would be his old wage. Well, his old wage was 18. So how much is he making now? What did you figure for that one? $20.70 is correct. Okay, so he got this new raise. He's making $20.70. Then the head of the company comes in and he says, hey, times are tough. Everybody takes a 15% pay cut. We're taking our raise back. Well, a 15% pay cut means less than 100. So his new pay is going to be 85% of what he was making, right? Well, his old pay is now $20.70. So what's his new pay? $17.60. What do you notice about this example? Yeah, he's making less than what he started with. Exactly. So you give 15%, you take 15% away. You are not back to where you started. Relative change is not additive. You can't take it away and then give it and have it match up. It doesn't work that way, right? If they had just said, we're going to give you $1 raise, that would have put him at 19. Then if they would take $1 away, we'd be back to 18. So absolute change is additive. You can take it away, give it back, and it evens out. But percents aren't like that, because percents are based off of your current value. And that changes things, right? Percentages change. So make sure you're very, very cautious. And if you can't remember if something works like that or not, just do a quick example like this. Start with $10. Give yourself a 10% raise and then take 10% away and see what happens. And you'll see that the percents never come out nicely. Okay. One more for this section, and then we're going to move on to 25, and we'll get through as much of 25 as we can, and then we'll pick up the rest next week. Okay, so this is, there are 2 or 3 problems in section 24 that are like this, and they tend to be the ones that people have the most trouble with. So the percent of people who smoke has decreased 8% in the last 10 years and is now 12.5%. What percent of people smoked 10 years ago? And the reason these tend to be the most difficult is because we have 2 different percentages written here. So it's hard to decide, you know, what percent do I go with 100, right? But remember, percents can also be like percentage points, and that's different. So the key is to find either decreased in this case or increased, because whatever percent is with that word, decreased or increased, that is the percentage that you use with 100 for your ratio. So decreased 8%, that means we're going to take away, because decrease means get smaller. So our ratio is going to be 92 over 100. Right? That's our ratio. Now we have to determine what is happening, right? We're talking about now, and we're talking about 10 years ago. So which one was bigger? So let's think about this. The percent of people who smoke has decreased in the last 10 years and is now. So it's going down, right? So now is smaller than then, if that makes sense, right? So it's now 12.5%. So the 12.5 is on top and X is on the bottom. Because what was it 10 years ago? Well, it was higher 10 years ago because it's decreased. Let me know if I'm not making any sense, because that does happen from time to time. All right, so we solve this proportion. Yeah, roughly 13.6% of people smoked 10 years ago, according to this made-up problem that I did. Okay. Everybody see where those numbers came from and how I decided now was on the top and then was on the bottom? Any questions? Section 3, 23, 24. And as you're working through the homework of those sections, of course, there's some that don't have videos. If you need a video, all you got to do is shoot me a text and I will hook you up. So just let me know. All right, so I want to get into section 25 just a little bit here. 25 and 26, as I said earlier, go together. So I'm just going to roll through these slides for 13 minutes. We'll just go till 3 o'clock. And then whatever we don't finish today, we'll finish next week, right? It'll be great. So section 25 and 26 get into linear models and scatter plots. So I don't know how much you remember about linear models and scatter plots from your high school days, but that's the beauty of what we're going to deal with. So do any of you remember anything about slope or y-intercept? Caitlin, yes. What? That's our model. I'm gonna. Oh, where's my pen? Here we go. The model is y equals mx plus b. Wow, that's a horrible color. Let's try that again. This might be a horrible background. It's possible. There we go. Y equals mx plus b. That is what we call our linear model, and we're going to use that a lot. The slope part of that is m, and the y-intercept part of that is b. So let's kind of go with that. If nothing else, let's at least get the vocab out of the way. So the slope is our constant change, and it's found by taking y2 minus y1 over x2 minus x1, where x and y become an ordered pair on the line. The little numbers next to them just let you know that the one with the x, so x1 and y1, those ones just say those are a pair. They go together. So the 2's are a pair. They go together. That's the only purpose of those little letters. So you have two different pairs. The y values go on top. The x values go on the bottom. The y-intercept we often refer to as a starting point. Okay, so it's a one-time thing. One time. You can only have a y-intercept one time. It's where the graph, the line crosses the y-axis. And so if we think about this, here's our coordinate plane, right? This is x, this is y. Just a refresher, because if you haven't done this in a while, it's gone. And that's okay, because if you don't use it, you lose it. That's math, that's life, and it's okay. We got this. So remember, like, this is the y-axis. So if your point is on this line, it's considered the y-intercept. Well, we can only have one. But one thing to remember is that we did not have to go right or left on the x-axis. So in order to have a y-intercept, x has to be 0. So we're going to have an ordered pair of 0. I'm just going to use the letter B because that's what y-intercept stands for. But the only numerical part you're going to have is in that second piece. Okay, and it can be negative. You know, the model is y equals mx plus b, but if your y value falls down here, it can be a negative. So that is quite possible. Okay, if you're freaking out right now because it's been a long time since you've done any of this, I definitely recommend watching all the videos that go with the packet. And there are additional videos that go at the back of the packet. And so the more you do these, the easier it gets. So if you're not sure where to find all those videos, shoot me an email. I'll send you direct links because I don't want you to feel overwhelmed. It's once you get going, it's not bad, but it can be a little overwhelming at first, and that's okay, right? We're here to help. We'll get you through it. Okay, let's do one example. I don't know if we'll get through more than that, but let's try this one. So the cost of a cell phone plan is $30 a month plus 10 cents per minute. Okay, now when you're thinking through $30 a month plus 10 cents a minute, if you think about our linear model, slope is a constant change. It happens over and over and over and over and over and over. The y-intercept is a one-time fee or a one-time thing. So when you read this initial problem, do either of these numbers stand out as a one-time thing, or do either one of them stand out as a constant reoccurring piece? Either one of those. What do you see? The monthly payment is reoccurring. You both agree to that. That's per month. True. Every month you have $30. Let's pretend, let's be more specific here. We're talking about just 1 month. So just the month of November, since that's the month we're in. Do you pay that $30 a month more than one time in November? No, right? So if we're just talking about 1 month, we only pay that $30 one time. What about that 10 cents? Do we pay that 10 cents one time, or do we pay that multiple times? Multiple, right? Because it really depends on how many minutes we talk. So the slope will be the 10 cents because that's what's going to happen multiple times, assuming you actually talk on the phone. And the y-intercept is going to be 30 because that's what happens one time. Okay, I need to add 1 month in there because you're right, that's not very clear. Okay, so in 1 month, we're talking about the cost of a cell phone plan. So if I know that the y-intercept is 30, the slope is 10 cents, what does my linear model look like? Always starts with y. What comes after the equal sign? $0.10, very good. Our slope. The value of x is always attached to the slope. And then I have plus 30. And I use plus because this is the cost of a cell phone bill, and 30 you're paying, so it's in addition to. Okay, the x and the y are always going to be a part of the model because they represent every possible ordered pair that would go on this line. So if I would graph this line, right, this line would look something like this. And that xy would represent any point on that line. So any point that I would graph on this line would have an ordered pair, and that ordered pair would fit into that xy piece there. Okay. All All right, so what do X and Y represent? This is kind of an important thing to be able to recognize. So let's talk about X first. X is attached to the 10 cents. What does the 10 cents represent? You pay 10 cents per minute. Exactly. So X represents the number of minutes. If you only talk for 1 minute, you only owe 10 cents. You talk for 10 minutes, you owe $1. So X is the number of minutes that you talk because it's 10 cents per minute. So it kind of gives it away. Any idea what Y stands for? Total payment. Exactly. So Y is either total payment or total cost, anything that deals with money, right? But you pay that $30 fee. There's the the Y-intercept plus however many minutes you talk. So it's the total cost for that month of a cell phone plan. All right, so now let's look at letter E. What's the monthly cost when you talk for 76 minutes? What do we do with that 76 minutes? You put it in for X. Very good. It's minutes. Minutes is X. So Y equals 0.1076 plus 30. And then it's order of operations. So you do just need to make sure that you multiply these numbers first, then add your $30. And what would be the total cost if you talk for 76 minutes? $37.60. Very good. Now in letter F, we can work backwards. How many minutes did you talk if the monthly cost is $43? Well, what do I do with that 43? Well, that's the monthly cost, so I plug it in for Y. So Y equals 10 cents times X plus 30. And let's go ahead and walk through the steps of how to solve this equation, right? Our goal is to get this X by itself. So what is my first step in getting X by itself? We're going to subtract 30 from both sides. Okay, so whatever's attached to X is our last step. So we're going to subtract 30 from both sides first, and that gives us 13 equals 10 cents X. And then as Caitlin mentioned, we will divide by 0.10. And that gives us 130 minutes. You're good. You had the second step. They came in order on the chat box. First we had minus 30, then we had divide by 0.10. So you always want whatever's touching X, that comes at the very, very last piece of the puzzle. Okay, so that's just the beginning of section 25, which isn't bad. So next week, we're going to pick up with the rest of section 25, and then we will do section 26, 27, and 28. And again, that won't be bad because section 25 and 26 go together. They're both linear modeling and scatter plots. And then section 27 and 28 are exponentials. So one's growth, one's decay, right? Growth goes up, decay goes down. Woo, there's the difference. You add in one, you subtract in the other. No problems at all. So did we talk about project 3? Did I give you any information on project 3? I feel like I haven't talked to you guys in months, so I don't know what you have or what you need. Do you need project 3 for you guys? It's basically about financials, right? And you just I am going to be grading project 2 for you guys in the next couple days here, but project 3, you need section 22, which we did today. Right, so it's over the financial sections. So sections 19, 20, 21, and 22 will come together. Do we need to talk about project 3, or do you guys feel like you can read the paper and figure it out? Thoughts on that? Have any of you looked at project 3? This is going to be a very compacted, I mean, the final exam is in 2 weeks. So, 4 sections, well, 3.5 sections this week, 3.5 sections next week. There's just going to be a lot to do, and you want to make sure that you're keeping up on things, because if you get behind, that last week is going to be rough. Okay, so let's do this. Look at project 3 before next week. That way, if you have questions, we can get those questions answered next week. Because next week is our last informational piece, right? The third, the 12th. Yep, the 12th, that's final exam week. So it'll be a question answer section. And I think your last project is due on the 13th, I think. 13th or 15th, I don't remember off the top of my head. So if you wait until the 12th, it might be too late. You might not have enough time to get it all done. But if you haven't scheduled your exam for that week, I recommend doing that this week, because remember, every online class for every discipline is taking a final exam that week. And so you're going to have to fight, not literally fight, but you're gonna have some challengers for spots for test taking. So if you pick the day and time that you want to take it, and then just dedicate yourself that you're going to be ready by that time, would be a good option for you. Okay. But if you don't have any other questions, it's 3 o'clock, so we're going to be done for the day. Let me know if you have any other questions, and I will be on my computer most of this week, all hours of the day, catching up on different things. So I will, if you have questions on things, we'll go from there. When it asks, I think it's just called exam 3 is what the exam. It's not a final exam. I think it's just exam 3. That's a good question. Yep, so try that. And the paperwork's there, so you should be good to go. So, all right.